Well, I've been continuing recently to develop it, and now writing a book on it with my colleague Basil Hiley, and we're getting more interest from some of the philosophers of science, and I don't know, some physicists. And I think maybe it will increase.
I see. So we digress to get to that point, to go back to the 60s, and we're still following the line. We were on the wholeness and the implicate order.
Yeah, well, I mean, this is part of it, to say
leading up to it.
Now, you see, then I went, you see, at that point I got, I got in touch with this man, Krishnamurti. There in the public library there was a book, and in that book there was a phrase, the observer and the observed, you see, and I thought this fellow would, was on the same line as I.
Could we pause there for a moment now, because that's a giant leap for some of us. As I understand it, the observer and the observed had been introduced as a perception by Werner Heisenberg.
Well, Bohr first.
Bohr first, and then
Heisenberg.
Taken up by.
Well, both about the same time in different ways, and
so
that was my interest, the oneness of the observer and the observed, which was due, according to them, to the indivisible quantum link between observer and observed.
Really? Okay.
And this was partly responsible for the analogy between thought and quantum process, right, which I mentioned before.
Right.
You got it?
Right. So you were in the library one afternoon.
Well, actually, it was my wife who was in there, and she found the book and saw the phrase, and she always objects to my bringing it up. So, but anyway, I read the book very avidly, and I said, okay, I must talk with this man. And he hadn't been, well, I wrote to the publisher, and apparently he'd been ill for a while, but he was coming to England and to talk. And
what year was this?
1961.
61.
And so I met him in London, and we had a very, he didn't know any physics, but still he listened to me talk about it. With very great interest. And
so it was a warm attraction to each other from the very beginning.
Yeah, we sort of had an instant communication. And you may ask, why was I interested in a man like Krishnamurti? You would think people might have thought of him as a mystic. Well, I was getting interested in all sorts of broader philosophy then. I had the notion that I think part of my whole cosmology was that the mind and matter were interconnected, two sides of one thing. And therefore, that we not only had connection to the world through the senses, but in some deeper level.
Of course.
And I thought maybe somebody like Krishnamurti, with all the perceptions that he had, which I could read about, would perhaps have been in that, had that possibility.
And those perceptions are manifested in everyday life. He was trying to explain those.
Well, but he sort of perceived. It seemed to me he sort of perceived directly some sort of wholeness, this wholeness of the universe and the observer and the observed and so on. So I didn't know quite what it meant, but it sort of looked as if it would be important. And if you remember that I always felt I would like to get beyond all limits. I mean, I didn't want to stay within the limits of physics as physicists had defined it.
Really?
I was already getting to the point where I said I couldn't stay there any longer. And
in fact, you had even thought about leaving physics.
Yes, well, even in the early 50s, late 40s rather, when just after the war, that attitude became prevalent, and I was thinking of it. But but I didn't actually leave physics. But anyway, I did follow this thing up with Krishnamurti, and we met every year when he came to London, and later I went to Switzerland where he gave talks, and later he established a school near London, and I used to take part in that. Now, we had many discussions, you see. Now, I think partly through these discussions, although not entirely, I came to this idea of the implicate order. At least it greatly encouraged me in that direction. I may have had the idea before in a very germ form, but...
Could we pause there for a moment again? The term implicate,
yeah,
it seems to be connected to the word imply.
And enfold, yes. The word implicate is the same root as imply. It means enfold.
Enfold.
In Latin, and explicate, to unfold, and explicit. Right?
Explicit.
Yeah, so if you say one thought implies another, it means that the thought is unfolded, right?
Mm-hmm.
Unfolds.
In other words, if I'm speaking of something, it may imply something else.
Yeah, but
and
that's
there's
already unfolded in your mind.
Right.
And it comes out and becomes explicit. Now, the idea was that you can think, say, of a piece of paper which you fold up many times and you make little cuts in it. When you unfold it, a whole pattern appears, right?
Right.
Many other ideas and examples would come to mind, but I haven't time, really.
Right, but essentially you're saying that would be the unfolded part, would be when it's...
when it's all together,
and then when it
unfolds.
becomes...
But then there's a reverse process of unfolding.
Unfolding again.
Now, I saw that you could understand the quantum mechanics in terms of that process, that instead of saying an electron, for example, is a particle just moving along, you could think that there's a wave coming in, unfolding. It's really unfolding to a point. It's unfolded in the whole universe. And then it folds back. Then another wave comes in a slightly different point. So you get a series of points that are very close together, so we imagine they're a particle, right? But because of that wave nature from which it comes, you understand the wave-particle nature. That is, it's a wave. You understand that.
And because we're used to seeing things in movement on this macro level,
Yeah.
the assumption has been that that's the way the electron...
Yeah. Yes, we've been extrapolating and then when you found the way the macro level works, and when you found in quantum mechanics it didn't make sense, you said there's nothing more to do except calculate, right?
Could we, again, that was found, that was the quantum, the term quantum itself has its base in that?
Well, the quantum, that's one of the features of quantum theory. Quantum has its base in the fact that energy is transferred in discrete jumps, or quanta, and rather than continuously.
I see.
Now, you can see that some sort of quantum appears here, that the wave comes to a point, then there's a jump to another point. See, one thing, according to quantum theory, was the electron could go from one state to another without passing in between. Now, you said that is utter mystery, right?
Right.
But you see, if the wave comes into this point, then it spreads out, it could come into another point.
Into another one.
You see, so therefore it needn't look so mysterious.
Is it possible to state that that's the way thought, the thinking process?
Yes, we could anticipate by saying that's how the thinking process goes. It goes in, it's unfolded in your consciousness, it unfolds to a certain thought, folds back, and the next thought appears different. A series of thoughts not too different seem to be continuous, right?
And is that where the now popular term quantum leap has its origins, actually?
Well, those jumps, yes.
Those jumps.
Yes, they take the idea of a jump that doesn't pass in between.
So there's no way of knowing how it gets from point A to point B on a macro level.
No, that jump is creative, you see. In other words, from the explanation I gave, that
Surely.
you see, to say the quantum jump or quantum leap is a creative process.
And you're suggesting that in the implicate order that it manifests in another place as opposed to actually
that's right.
traveling from point A to point B.
Yeah.
So that was the basic line of reasoning in the wholeness and the implicate order work.
And which connected consciousness with matter, because they had a parallel process, right?
In other words, at that basic implicate level, all
existence, all being.
All being was
in one order. I call it the implicate order because it's the order of enfoldment that counts, not the order of movement on a line.
So that the greater, the action itself really takes place in the implicate.
Yes.
And
it manifests in the explicate.
And it manifests in the explicate.
Yes. But it's part of the same tradition of science, saying that what we thought was the essence is now the appearance.
Say that again. Okay. What we thought was the essence
is now seen to be another appearance, right? Namely, that the particle which was explaining everything as the essence of reality
is appearance.
Is also an appearance.
Is also, in addition to its being essence.
No, everything is both essence and appearance in that sense. But you see, all appearances are essential.
Or else we wouldn't be able to see them.
They're all appearances, and the essence as the true being is unknown, right? Even the implicate order is merely a concept.
Surely.
So even that should turn out to be an appearance. But we say by bringing in deeper, more penetrating appearances, we understand better. That's all. We're never going to grasp the whole.
And that has its own implications in understanding the world as we perceive it.
Yes. Yes, see, this is against the view which a large number of physicists are coming out saying we're going to get a theory of everything, you see. Now, in the 19th century, after Newton had been so successful for several centuries, one of the leading physicists of the time, Lord Kelvin, said it's no use for young people to go into physics. It's nearly finished. It's only a matter of the next decimal point being refined. Try something else. So he said there are two small clouds on the horizon, the negative results of the Michelson-Morley experiment and the problems of black body radiation. These were the right clouds because each one of these led to a revolution, one to relativity, the other to quantum.
They were the wrong ones for Kelvin, unfortunately.
Well, he chose his clouds very well,
Very
but
carefully.
he thought they were small clouds, you see.
And in fact, the revolution
Came out of them. Now, we still have much bigger clouds on the horizon today.
at the present time, as a result of
No, but physics has developed onward into all sorts of new things, and a lot of things are not understood today. More serious than that was then, but people still talk of the theory of everything. They live in hope, you see.
I see. And this theory of everything, is it somehow tie into the unified theory that Einstein was?
Well, that would be to try a realization of Einstein. Yeah, there's no harm in having a unified theory, but just don't say it covers everything, because it will be also an appearance.
And essentially, you're saying that all theories are that. They are a way of looking at things as opposed
that's right,
to
yes.
an absolute
Yes,
truth.
it will be an appearance. You see, we'll have it will be an appearance which reflects, in principle, everything. You see, the whole, rather. See, we have all sorts of mirrors by which we can see different things. So this will be an appearance of a whole, which may even include ourselves. You see, in other words, we see ourselves in this mirror too.
Okay. Can I make a quantum leap and suggest that because, if such is the case, then to take our thinking process as absolute is a mistake.
Yes. Yes, just from
And the
scientific...
results of the thinking process as well.
Yes, now just from scientific point of view alone, it's a mistake. But it's a mistake. If you look directly at the process, you could see how serious that mistake is.
And so now, at the present time, you find that your work on consciousness is, in fact, parallel to the other work you're doing and in fact, possibly paramount. The book that you're bringing out, Mr. Hiley.
Well, that's on quantum theory. That's really an attempt to bring out some of the stuff we did, say, 30 years ago, or 40 years ago.
But it has to do with an approach other than Bohr's approach.
Yes, that's right.
Could you explain the difference between the two approaches?
Well, Bohr's approach is to say nothing can be said about it at all, but just to calculate, right?
I see.
Now, this attempts to give a concept of it, right?
Yes, a concept.
Another appearance, let's call it.
Another appearance. But it's heavily leaning toward meaning, as I understand.
Yes. Well, it gives more meaning in the sense that if we have the implicate order and so on with the consciousness in a similar order, we have a creative order which has more meaning, you see. See, in this mechanical order, it would be very hard to get much meaning, or in the order of just calculating things. And you see, as Steven Weinberg has said, one of the leading theoretical physicists of the time, that the more they look into the cosmos, the less they see meaning, you see. But that's inevitable if you say, anyway, you're just calculating, you see.
I see. And do you think that perception is permeating our society?
Well, it has an effect because ultimately society is highly affected by science as it once was by religion, which now has no longer the source of our worldview. Science is the source of the worldview that religion used to give, right? Now, the view of totality has great power because the view of totality in principle has supreme value. You see that. See, God, what would he be? He made everything, so he has the highest possible value. Now, if the universe, which has the highest possible value, is meaningless, then there's not what else can have value.
But in fact, in pursuing your avenue of inquiry, it is essentially attempting to bring meaning back into life.
Well, we say that there's no reason to do what they're doing. That's the first point.
Yes, yeah.
And the universe isn't what they say it is, so there's room in it for all sorts of unlimited meaning, you see. If you say the universe is even in matter is creative, then much more so in mind. Right?
I see. Are there aspects of consciousness in the new book that's coming out? Are they touched?
Well, we